Okay, this is a very quick video just to clarify the difference between the between group comparisons that we need to make with our statistical testing and the within group comparisons that we make. So I've made up some data here. I've got group A in green. I thought I'd colour code it just to make it a bit more digestible, and group B in yellow. And it doesn't, this is just made up data, so I just randomly typed in numbers. So this isn't a measurement of anything. So we have their pre-measurement and post-measurement. So there, you can assume there was an intervention of sorts in between. And I've also included here the change, which is basically just the difference between these two values. So I've used this equation here where I've subtracted the starting value, the pre-value, from this value here. Okay, that's all that is. It's the change, it's the difference. You could think of it as. And we have the same for group B. So we can work out our mean values in Excel. I'm going to show this in Excel instead of SPSS just to make life easier really for me. So remember, this is how we get our mean value. We type in equals average, open brackets, select our data column, enter, and we have our mean value here. We then drag and drop this over here and the numbers stay the same, but we now have our mean, which is our average value. We now want the standard deviation, which we did do in a recent video, but just to confirm, equals stdev.s, open brackets, select the data again, close brackets, enter, there we go, and then we can just drag and drop this along. Okay, everything stays the same. So, that's the sort of most basic measurement that we need so far. Now, when I say between group and when I say within group comparison, I'm referring to the sort of statistical tests that you're going to do. So, I'm going to assume this data is normally distributed. I've made it up. I don't know if it is. It probably isn't, but I'm going to pretend it is. Okay? So, that means I am happy to use t-tests and a variation thereof. So, we have different points we can compare, or different sets of data we can compare. We can compare group A pre with group A post. That's one point of comparison. And group B pre with group B post. So because we are comparing before and after within each group, group A. We're not comparing A to B, we're not at that stage, we're just comparing what were the values when they started, what were the values when they finished. This is a within group comparison, therefore the same participants are being used. We have the same participants here and here. So you could put the participant numbers down here, I suppose, if I thought ahead. Let's do that. P1, P2, P3, P4, whoops, 4P, 4, P5, P6, P7, you can forward this bit if you want, P8, there we are. So there are participants. So at this point, we're just comparing within the group. So in this case, we would use a paired samples t-test, or a within group t-test, okay, for both assessments, or for both sets of data. Okay, because we're just comparing within a group. Now, I've already done these tests just to see, out of curiosity, if there is a difference. Now, the next 3 points of comparison we can make are Group A pre to Group B pre, and the one that we're really interested in is Group A post to Group B post. Why are we interested? Because the pre values should be the same, we're hoping. This just because they haven't received our intervention yet. The post values mean they've both gone through our intervention, whatever it is. Let's say it's cycling with caffeine supplementation or a placebo control. This is where we're hoping to see, but we obviously don't, we can't skew our results. We need to be unbiased, but that's where we want to see our differences, here and here. So here is a between group comparison. Now what you can also do is compare the change in Group A to the change in Group B. So there's another point of comparison that you can make. So it could be possible that the post-intervention values aren't different, but the actual difference between the two within group might be different between groups, if that makes sense. So here and here. Either way, for this, we need our, where are we? Two-sampled t-test, what we could sometimes refer to as an unpaired t-test, assuming equal variance, which is, again, for the sake of this demonstration, I'm not going to go through with the Sharper-Wilks test. So here we are, that's what we're doing, and I can reveal that I've done my tests, and to much disappointment there, so these outputs here are the within group comparison, so you can see pre-post for Group A, pre-post for Group B. So this value, I'll get rid of that. If you get a p-value like this is what is called a scientific notation. So this is 4.13, in fact let me zoom in, doodly-doo. 4.1379 minus 7, sorry. So all this means is this is a way, because this number is so small, this is the same as saying that there are, I have to count these out, the p-value is 0.0, 1, 2, 3, 4, 5, 6, 7, 4, 1, 3, 7, 9. There we are, that is our, oh, there we are, it's, again, it's turned it into scientific notation, but you can see it here. There. There's our p-value. I shouldn't have clicked away. So that's extremely significant. That's well under any p-value we could ever set. So Group A did see a significant change pre versus post. Okay. So this is our other paired t-test that we did, and again we have the two-tailed t-test. We don't use one-tailed, use two-tailed. I mean, you can use one-tailed, but we tend to use two-tailed. There simply wasn't time to go into this two-tailed versus one-tailed, but you'll learn about this in your second year. So this is the same as saying that the p-value is 0.1234563 98809. So that is again an extremely significant number, and it's gone and put it in scientific notation. Oh, I must have done too many zeros. Okay, alright, well, you get the idea. Oh, I've done too many zeros here. So either way, that is extremely significant. However, unfortunately, when I did the between group, so this is group A pre versus group B pre, the p-value was 0.7. And group A post versus group B post, 0.6. So no significance there. The only one I haven't tested, which I'll do now quickly, is the change. So we're going to assume equal variance, because why not? You, of course, will do your Shapiro-Wilk test to find out if your data is normally distributed. I'm not going to bother with this example, as I say. Okay, put that there. What have we got? Oh, okay, so there we are. So the change between the two groups was significantly different. Ah, rejoice. So group B is significantly higher. The mean for group B, which is 18.7 if we round up, and group A 13.9, sorry. So group B is significantly higher than group A. So there we are, we have significance. So that's quite nice then. So how do we represent this in our table of results if we choose to present it that way? Well, I'll full screen this. Here's one I made earlier, as they say. So underneath you would have a small descriptor explaining what this means. So we said that group A pre and post and group B pre and post had a significant difference. So we could represent that with an asterisk like this. In fact, it would be, for a p-value that small, you would put 3 asterisks, because the p-value was less than 0.001. Okay, and in your descriptor you would simply write something like equals p less than 0.01 within, oh, I've got capitals on, within groups. What can I spell? Okay, or within group you could just put. Okay, now if you're going to do between group significance, you can't obviously use the same asterisk symbol, so it's up to you to choose a symbol of your that you think is appropriate. So very often, where's it gone? I mean, you can just use anything, but obviously you want to be sensible. Don't use sort of the trademark sign or anything like that. Well, let's use this. So we've had this before. I've been told to use this before. So okay. So again, I've been told different journals want you to do different things. So there's some journals that have said use dollar signs, so use that to indicate statistical significance. So our p-value was, I forget now, what do we have, 0.01. Okay, so that's less than 0.05, but it's not less than 0.01, it is 0.01, so we would just put 1 of our little, I don't know what the symbol is, perhaps someone can tell me, and we can say that this symbol indicates that P is less than, that should be capital Y, 0.05 between group. If you want to do it properly, then the P in both cases should be italicized like that. Okay, and this would just be in a little descriptor underneath your box, so this text should be smaller. So they would say font size 8 and should be more tightly packed together. There we go, underneath your table. So that's it really. We've used the asterisk symbol to show within group differences here, if they're significant, of course. So this is indicating, yeah, there's a significant increase from pre to post. And here again, you can see, yeah, significant increase from group B's pre to group B's post value. And this, however, indicates, this symbol here indicates that there is a between groups significance. So let's just pretend that this value here and this value here were statistically significant. No, we'll go with this one. We'll go with this one here. Let's just say these two values here were statistically significant between groups. So in that case, you just add that as well. And say, yeah, so there was both a within group and a between group significance. That's it. You don't need to put asterisks in both cells if you don't want to. You can just do one there. So that makes it look a bit tidier. Again, it varies between journals, but if you do this and use the asterisk notation, say within group, then we will know what you, oh sorry, we needed that one. I don't know why I got rid of that. People will know that that means within group, so that means here to here, here to here, and this significance was occurred between this data set here and this data set here. Okay, I hope that helps. So just to emphasize what I've reported here, we have the mean for each value and the standard deviation, which we worked out in Excel. I hope that helps for anyone that's wondering about this topic and isn't quite clear on how to report significance if you have any in your work.